In this video, we'll be finding the directional derivatives for a function of three variables. Here we want to find the directional derivative of a function of x, y, z, where f of x, y, z equals x, y, z in the direction of the vector v, which equals 2i plus j plus 2k at the point 2, 1, 1. Now here we have the formula for a directional derivative for a function of three variables. Notice we'll be using the partial derivatives with respect to x, y, and z, but we also want to find a, b, and c. Now a, b, and c are the components of the unit vector. So we need to take our vector v and make it a unit vector. So we take our vector v, which I'm going to switch to the angle bracket notation here, 2, 1, 2, and we're going to divide vector v by the magnitude of vector v. And the magnitude of vector v is found by taking each of the components, squaring, and adding the results. And when you do that, you get, in the denominator, you get the square root of, square root of 9, which is 3. So we're going to divide each of those components by 3 to get our values for a, b, and c. So 2 divided by 3, 1 divided by 3, and 2 divided by 3. Those are the components of your unit vector that's pointing in the direction where you want to find the directional derivative. So that's going to be our ABC. So using this formula here, we are going to find the directional derivative of the function in the direction of the u vector. We're given the v vector and we had to make it a unit vector. So it's going to be a, where a is the first component here, 2/3, times the derivative, or the partial derivative of our function with respect to x. When you take the derivative with respect to x, you treat x as a variable and treat y and z as constants. So x times a constant, the derivative is that constant, which is yz, plus the b is the second component of our unit vector, 1/3, times the partial derivative of our function with respect to y. Treat y as a variable and x and z are both, treat them as constants. So you get that partial derivative is x times z, plus our c now is the third component of the unit vector, which is 2/3, times the partial derivative of this function with respect to z. Treat z as a variable and x and y as constants, and you get that partial derivative as x times y. Now we are ready to plug in the point 2, 1, 1. So the directional derivative in the direction of that unit vector of the function evaluated at the point 2, 1, 1, we're plugging in 2 for x, 1 for y, and 1 for z. So that gives us 2/3 times 1 times 1 plus 1/3 times 2 times 1 plus 2/3 times 2 times 1. Now when we simplify that, that is 2/3 plus 2/3 plus 4/3, and that is equal to 2/3 times 2/3, that's 4/3, plus another, that's 8/3. So for this function of three variables, the change in that f with respect to that change in f at the point here, looking in the direction of this vector, is 8/3. Okay, for this example, we want to find the directional derivative of this function of three variables, which equals x, y, e to the z, at the point 2, 4, 0, in the direction of the point q, which is 0, 0, 0. So in order to find the components of a, b, and c, we need to find a unit vector that is pointing in the same direction. So what we'll do here is we have this point P looking in the direction of Q. We can find a vector from P to Q. And remember, when you're finding the components of a vector, you take the terminal point and subtract the initial point. So it's going to be 0 minus 2. And I'm going to use the angle bracket notation. So that vector is -2 for the first component, 0 minus 4, That's negative 4, and 0 minus 0. So that is your vector that is pointing in the direction where you want to find the derivative. Now we need to make this vector a unit vector. We do that by dividing by the magnitude. So if we divide by the magnitude, negative 2 quantity squared plus negative 4 quantity squared, add those together, and then take the square root of that. And then you're going to divide each of the components by that. And that looks like the square root of 20. So it'd be negative 2 over the square root of 20, negative 4 over the square root of 20, and 0. So those are the components of your unit vector, and we're going to use those for the values of a, b, and c in our directional derivative formula. Now we're going to go ahead and use the formula for the directional derivative. The directional derivative in the direction of that unit vector of a function of 3 variables is equal to the a in this case is the negative 2 over square root of 20 times the partial derivative of our function with respect to x. You're going to treat x as a variable and y as z and z as constants. So that is going to be y e to the z plus our b, which is negative 4 over the square root of 20, times the partial derivative with respect to y. You treat y as a variable and x and z as constants, and that partial derivative is x e to the z, plus our third component, our c, is 0 times the partial derivative of this with respect to z, and that partial derivative would be xy e to the z. So this would be our directional derivative. Now we can determine what that is at our given point, evaluated at P. Our directional derivative in the direction of that unit vector from P to Q, a unit vector that's going in that direction, evaluated when x is equal to 2, y is equal to 4, and z is equal to 0. Let's go ahead and plug those in. So we get negative 2 over the square root of 20 times 4 times e to the 0, and e to the 0 is equal to 1, so we can simplify that, minus 4 over the square root of 20 times x times e to the 0 power, where x is equal to 2, and plus 0 times all of that. That's going to be 0. So this is going to simplify to negative 2 times 4 over the square root of 20 minus 4 times 2 over the square root of 20. That's negative 8 over square root of 20 minus 8 over square root of 20, which is minus 16 over the square root of 20. Okay, and of course that could be simplified, but we'll leave that up to you.